Good evening, everyone. So I am going to discuss about the topic work done by the thermodynamics process, isobaric process, isochoric process, isothermal process, and adiabatic process. So these are the work done by all the process we will discuss one by one. So before understanding isobaric, isochoric, isothermal, and adiabatic work, we need to understand what actually work happens. Where does this work happens? Okay. Now let us consider this is a piston cylinder. Okay, so work is done on the thermodynamic system. See here, in this system, there is a cylinder, and this one is a piston. This part is a piston. This part, the movable part, is the piston, and the gas is here. So gas sometime exhaust comes in, comes out, and there will be due to the gas expansion at all, there is a movement comes out, and heat is being generated here. So these are the piston and cylinder, and here what happened, this gas, this gas expand suddenly. So gas expands suddenly. So what will happen? So due to gas, the pressure is created, and pressure when created, it's do a work on this piston. So there will be a movement, and whenever there is a movement, then there will be a work done. Okay, so the work done is due to the excess pressure of the gas inside the system. So we will discuss one by one each of the following things. Okay, so let us consider how you will find a work done. Now before that, we need to understand what is here. So see here, see this is the cylinder, this one is the piston, there is a pressure, and the area of the piston is this is the area of the piston, and it is denoted as A. As soon as pressure P is there, so when there is a pressure, due to increase in a pressure or due to the gas, what will happen, there will be a displacement dx. So let the pressure of the gas will be P, and due to that pressure there is a movement of a piston, and let a small displacement dx will happen. So due to this pressure, what is happening here, there is a small displacement of this piston will happen, and then the volume of this changes will happen as it goes up. So what will happen, volume change will happen. Okay, so this is what, due to the gas on pressure, there is a movement in the piston, and the piston moved about dx length, and the area of the piston is A, and due to this what happened, there is a change in a volume as the gas has expanded. So as you can see here, see, volume of the gas is changing. Some in contraction it is decreasing, in expansion it is increasing. So this is the what we are talking about. Now while moving a piston, gas has to work on the piston. As soon as it will move, so it means that gas is doing a work on the piston. So the area is same, dx is same. So can we write here, force is equal to pressure into area? So we can write here, as we know that, let us dw be the small work done by the gas. So dw is equal to force into displacement. So in case of force, we can write here pressure into area into dx. So when we multiply area into dx, means what, change in a volume only. So finally we have got dw is equal to p into dv. This is the work done by the gas on the piston. So whenever this type of system will come, so we have to find like this only. Now as dw is equal to p dv, so by integrating, if we integrate both the side, why we integrate both the side, the thing is that when pressure changes, so when it expands, so pressure also varies. So we don't know the conditions, so that's why we have to use pressure. It is either variable or constant, it decide upon the factor. So that's why we don't know about that thing, but the total work done for entire process will be integration of dw. So finally dw will be equal to p into dv, and it may be v1 v2, it may be t1 t2, it depend upon the situation. So you have understood how to find the work done. Now let us see here. First of all, I will discuss about the work done due to the Isobaric pressure. Isobaric. What is isobaric? Iso. Iso means constant. Bar means pressure. So here what happens? Pressure remain constant. How pressure remain constant? From this diagram you can understood well. As we apply a heat, so what happen? It is going to expand. So the pressure will remain constant because it won't able to increase the pressure. But when you talk about the left side pressure cylinder, what happen? No matter how much you are applying a heat, so it has been fixed, so it means that volume will remain constant. But here what happened? Pressure will remain constant but the volume is changing. So this is the condition. Okay, so we have already discussed about the process. So these are the process happening. We need to find the work done on a isobaric, that is pressure will remain constant. So this is the situation where pressure will remain constant. Now let us see here. Since pressure will remain constant, so work done can be written as V1 to V2 PdV. Since pressure remain constant, so we can make it out because constant terms can make out before integration. So it is V1 to V2 into dV. So the integration of dV is V. So when we put this, so what will happen? See here, integration of V is dV is V. So finally we can put the limit V1 and V2. So finally we will get the work done. So work done is equal to P into V2 by V2 minus V1. So due to increase in the internal energy, there will be a change in the volume. Okay, whenever we will apply heat, so what will happen? Volume is changing. And if you are doing a volume change, so it means that you are applying a work, or a gas is applying a work. So finally you have understood how to find the work. So this is the very important formula: work done for only for isobaric process, that is pressure should remain constant. See here, work done. See here, after applying heat, when we apply heat, so what will happen? Volume may changes to V2, temperature may changes to T2, but pressure P1 will remain equal to P2. So dW is equal to PdV. Again, pressure will remain constant, so P1 will be equal to P2. So if we integrate both the sides, so we will get this thing. Same thing, just I have repeated this, okay, so that you will able to understand it properly. So finally, work done for the constant pressure process is equal to P into V2 minus V1. Now let us discuss about the work done by the isochoric process. As we think about isochoric process, means volume will remain constant. See, in the system, volume of the gas will remain constant. Why? Because we have put we have fixed this piston. So how much you apply heat, so it won't able to go out. No matter how much energy will increase by applying external heat, volume will remain constant. Okay. Now if volume will remain constant, so how you will find a work done? So since volume will remain constant, what do you mean by this? It means that V1 is equal to V2. It means that change in volume, that is dV, is equal to V2 minus V1. Since both are same, so volume will remain constant, so dV will remain equal to 0. Now we know that what is the formula for work done. Work done is equal to integration of P dV. Work done is equal to integration of P dV. So dV is 0, so that's why integration P into 0, finally 0. So hence the important thing is that work done in an isochoric process will be 0. Okay. Now let us work done by the isothermal process. Isothermal means what? Temperature will remain constant. So since temperature will remain constant, it means what? It means what? It means what? Pressure PV equal to nRT. So N is the constant term, R is the gas constant, T is the temperature constant. So whole three are constant. It means what? PV is equal to constant. So P can be written as constant by volume only. Yes. Or one more thing we should write here. PV equal to constant. It means what? B1 is equal to P2 V2 also we can write. Even we can also write P3 V3 also. Okay. So whenever this type of things will come, so you have to write like this. So as we know that work done is equal to PdV. integration of PdV. Now here what happened? Pressure was P1, volume was V1, temperature was T1. So there is some expansion, pressure will increase, volume will increase, but at the same time temperature will remain constant. This is very important. Okay, so now we need to find work done. Okay, so here uh, work done work done by the isothermal process. So here we what we are doing, work done is equal to P into dV. So here what we can do, as we know that PV is equal to constant. See here, since PV is equal to constant, so P can be written as constant by volume only. So what I have done here, in place of pressure, I have write in terms of constant divided by volume. So constant terms will get out. So what will happen? So it will be dV by V from V1 to V2. So finally, dV by V is your log V. So this step I have skipped. So this will be C into log V, and the volume will change from V1 to V2. So finally, you will get C into log V2 minus V1. Okay, so this is a log V2 minus V1. Okay, so we can convert it into work done is equal to P1 V1 by log V2 by V1, because log A minus log B is equal to log V2 minus V1. Why I have written C as a, we can write either P1 V1, we can also write C as a P2 V2. Why? Because just we have discussed this thing. Okay, so finally we can also write here PV is equal to mu into RT. So what will happen? Work done is equal to mu RT into log V2 by V1. Okay, so I hope you have understood this work done by the isothermal process. Now let us discuss about the work done by the adiabatic process. Adiabatic process. Okay, so work done by adiabatic process means what? You know that in adiabatic condition what happens? PV to the power gamma will be constant. So here P can also be written as C by V to the power gamma, or we can write here P1 V to the power because P V to the power gamma is equal to constant. This is the condition for the adiabatic process. So we can write here P1 V1 to the power gamma is equal to P2 V2 to the power gamma. Okay. Now, as we know that the common formula, that is work done is equal to P integration of P dV. In place of P, what we will write? C divided by V to the power gamma. Why? Because we have already taken this. Okay, so if we have written that like this, then what will happen? See here, constant, we make it outside, so integration from V1 to V2 dV by V to the power gamma. Okay, so integration of dV by V to the power gamma can be written as V to the power minus gamma plus 1 divided by minus gamma plus 1, and constant term will come out. So this will come from V1 to V2. So finally C into V to the power V2 minus gamma plus 1 minus V1 minus gamma plus 1 by minus gamma plus 1. So just you multiply, we can multiply C V to the power minus gamma plus 1 minus C to the power V1 minus gamma plus 1. We know that C can be written as P1 P2 V1 V2. See here, C can be written as P1 V1 to the power gamma is equal to V2 P2 V2 to the power gamma. So if we can write this, so finally what we are writing here? So C, in place of C, I have written P2 V2 to the power gamma. Why? Because it is already in the form of V2 here. So why not we can write here P2 into V to the power gamma? Why we should write P1? Because we are already getting V2 here. So same thing here, it is V1. So we have to put here V1 P1 into V1 to the power gamma. So if we add on, so finally we will get V2 P2 V2 minus P1 V1 divided by 1 minus gamma. So this is the work done by the adiabatic process. So work done by adiabatic process is equal to P2 V2 minus P1 B1 divided by 1 to the power gamma. Gamma is where gamma is a adiabatic index. Gamma is your adiabatic index. Adiabatic index. So in this way you will able to derive each and everything. Okay, so work done is equal, work done can also be written as like this. See here, since pb is equal to mu rt, p1 b1 is equal to mu1 mu rt1, p2 b2 is equal to mu rt2 t2. So we can put this value mu rt2 minus mu rt1 divided by 1 minus gamma. So mu r is a common, so what will happen, t2 minus t1 divided by 1 minus gamma. So finally work done is equal to mu r into T2 minus T1 divided by 1 minus gamma. So this is what the work done by the adiabatic process. Now let us discuss about the cyclic process. Cyclic process is what? The process in a thermodynamic system undergoes a several process will come into initial state. See here, it starts from here and it again went to the same process. As internal energy is state function, so initial and final state both are same, so change in internal energy for this case will be 0. So del u will be 0. And if we know that as per the law of thermodynamic, del q is equal to del u plus del u. So if del u is equal to 0, so del q will be equal to del w. Hence the total heat absorbed by the system is equal to total work done by the system. It means that there, if you are applying a heat and there is a cyclic process, then whatever you are applying a heat for 100 joule, so it will get converted into work done will get converted into 100 joule only. Okay, so this is what all about work done by cyclic process. I hope you have understood these things. Thank you for attending this class.